Hey, this is Matt with Two Guys Make Stuff. Welcome back to our studio. Today we're going to talk about, what are we talking about? Oh, we're going to talk about creating tools in Fusion 360 for plasma cutting. We're going to talk about the post-processing file and how you can get it. And I'm going to show you how to do a setup, and we're going to cut a piece on the plasma table. So I'm going to go from the drawing to creating the tool to setting it up, show you our post-processing file, and put it in the Mach 3, show you how we zero it out, and then start the cut. It should be pretty quick. So if you'll look now, I have this drawing for a wrench organizer that we're cutting out, and it's going to be 14 gauge steel. So if you can see now, the first thing that we want to do is, once we're into manufacturing, we'll go from design to manufacturing. So we're in manufacturing, and you'll see setup. You'll left click on setup, go to new setup, and it brings up this box, and you can see the X and the Y, and this is our models. So you want to go down here to where it says model on the right hand side in the dialog box, hit select, and then select both of those models. And then from there, this is our XYs. Now that is where the tool is going to start, where your cutter, where you set up 0 on your machine for where your cutter to start. And we want that to start on this corner. That's where we like to start. It makes it really easy to manage our material when we start always in the lower left corner. So once we have that set up, we hit OK. And then it's going to go to, then we go to cutting. We're going to left click on cutting, go to 2D profile, and it'll bring up this dialog box. I'll bring it over here for you. Now here in tool, that's where we want to hit select. Now it's going to bring up this other menu. You can see I already have 13 gauge fine cut selected. I'm just going to go ahead and delete that. Delete. Okay, so over here on the left, you'll see where it says local. You want to right click on local, and it'll say new library, new folder. I want to make a new library, so you left click new library, and then you can name it whatever you want. We'll name this YouTube cutting, enter. Now, see, we already have our library for plasma cutter, that's ours. But just for the purpose of this video, I'll show you YouTube cutting. So you click on that, you highlight it, and once it's highlighted, you'll see up here this blue plus sign. If you left click on that, it'll bring up new tool, and it'll give you all of these options. And we're going to go to cutting, and we're going to go to plasma cutter, and we'll left click on plasma cutter, and it'll open up this, and this brings up this. This is where you input all of your information. So the description, we're going to call this 14 gauge fine cut. And then cutter. Now where you're going to find all this information is from your cut sheets. This is our data cut sheet for our machine. We have a Hypertherm 45 XP, and this is where you're going to find all the information. So I'm just taking this information and inputting into this dialog box. So cutter, nozzle diameter, we don't care about that. Kerf width, so I'm going to look up the kerf width, and our kerf width is, for 14 gauge, is 0.049. Again, your information might be different depending on your plasma cutter, your machine. And then cutter, so we enter the kerf width. Holder, we don't care about that. Cutting data. So quality control, machine uses feeds, that's what we select for our machine. The cutting rate is 160 inches per minute for us. The cut height, 0.06. Pierce height is 0.15. Our cut power is 45. Pierce power, 45. You're just going to go down the list. Pierce time, 0.04 seconds. That's what we found works really good for us. The air pressure that we run is 80. And it's air cis gas. So then when all of that information is done, you have your description, the cutter, which is your kerf width, plasma cutter in inches, the cutting data, that's going to be your inches per minute, and your cut height. Then when that's done, you hit all that's done, you hit accept down on the lower right. Now you'll see it's already highlighted here, 14 gauge fine cut. So then you hit down here on the right lower, you hit select. Now that's going to bring up this tool in your tool section. And you can see it's plasma cutter, 14 gauge fine cut. Perfect, that's what we want. That's how you add a tool in Fusion 360. You can go through with your cut data and add every tool that you think that you might need to use for your machine, and you can go ahead and create that entire library. So next time you have something you need to cut, that information will already be there. Or you can add it as you go, your choice. So back to finishing this, we're going to go to geometry. So the first box was tool, the next box to the right is geometry. We'll click that. Now we're going to cut this entire part. So I'm just going to select this one, and I'm going to select this one. Heights, we don't care about that. Passes. On passes, we don't care about any of this, but you can go down here to smoothing and make sure you click smoothing. That's going to take out any unnecessary nodes that might be in the drawing code that the computer doesn't need. So the next important thing is you go to linking, and we're going to hit linking, and our lead in and lead out. Now you can mess with these, especially if you're going to do circles or holes. You can change this lead in sweep angle, lead in radius. We're going to put 0.02, and as you can see here, what that's going to do is that's going to add a little sweep to the lead in radius, or to the lead in and the lead out. All of this looks good. So one question we had was positions. If you want a specific place for your tool to start on each one of these cuts, you can tell it to. So we're here preferred lead in positions. Sorry, I can't speak. We're going to click on that, and then we want the first. We want it to lead in. Let's see. I don't care. Let's see. We'll lead in here, and on this one we'll lead in. We'll lead in there. And then once all that's checked, you hit OK. The computer will think, it'll go through, and now it's created the cut. Now to check your cut, go up here to cutting, or you can go down here, right click 2D profile, you'll click simulate, and hit play. This is where you can speed it up a little bit. And as you can see, it started and ended each cut right where you told it to. All that looks good. It captured all of our geometry, so we're going to exit simulation. Jeez. This is where we get into the post-processing. No, thank you. So our post-processing file, here, we'll go here. So go back to 2D profile, right click, go up to post-process, and it'll bring up this box. Name, number, this is what we're going to call it. Whatever you want to call it, this is what's going to be written onto your jump drive. So name it something that you will recognize. So we're going to call this wrench organizer 3. The post, this is the file that people were questioning. We have a custom Mach 3 post-processing file that we've downloaded into Fusion 360. That file is right here, and as you can see, it's lines and lines and lines of code, and this is what tells Fusion 360 to write the proper code for Mach 3, because that's what we use for our plasma cutters, Mach 3. Now, if you're using Fusion 360 and you're using Mach 3 and you need this post-processing code, there'll be a link in the description to our email address. Send me an email. I'll be happy to send you a copy of it. And then it's just a matter of going here to the file. Once you save it onto your computer, you upload it to this, and then it'll stay right there. So every time, and that's the file that we had to have, that we needed to run Mach 3 with Fusion 360. There was no other way. It was given to us, so we're happy to give it away to whoever needs it. So the post properties, the general, 031, the cut height, it's 0.06. And when you first put in this file, I'll warn you, when you first put in this file, all of these are going to be different. They're going to be different than these numbers, and according to your cutting machine, your plasma machine, torch, you need to put in this information as you see fit. So our cut height is 0.06, pierce delay is 0.04, pierce height is 0.15. The probe offset is negative 0.16. That's because we use torch height control, and the machine's going to come down, it's going to touch the material, and it's going to keep going to a negative 0.16, and then it'll come back up. And it uses that information to determine the height of the material in relationship to the nozzle of the plasma tip, the cutter. And then that's how it determines how high to cut in for the pierce and the cut height. And then the safe Z is 0.5. That's half of an inch. So that's the distance after it's made a cut that the nozzle will travel up before it travels to the next cut. And if you can play with that, sometimes we'll raise it up to 0.75 or to 1 inch. I'm sorry. And the reason why is if we're having a lot of things that when they cut, they fall down, and if they fall down in such a way that part of it will be sticking up that it would impede the travel of the nozzle, we want to avoid that. So that's where we will adjust the safe Z. Dwell on seconds. You can keep all of this just the same. Once all that's done, we're posting it to the D drive, which is our USB, and we click post. NC code successfully posted. Okay, so now we're just going to pull the USB drive. We're going to come right over here, put it into the computer. There we go. There you are. All right, now we're in the computer. You can see Mach 3. Cancel. And we're going to load code. There it is. Wrench organizer 3. Open. Hey, you can see it here. And then this is our X, our Y, and our 0. And you can see that they're all these crazy numbers because I just turned on the machine. But this is where we're going to put 0. That's 0. And that's where we drew 0, or we use 0 on the model in the manufacturing part of Fusion. So we set up our tool so it's 0. That's 0. So all I do now is I go and I hit 0, 0, 0, regen toolpath, and then we start our cut. That's going down. It's doing a negative 0.16, and it's doing the touchback. Okay, so you can see that's where it did a lead in and lead out. And that's the lead in and, whoops, sorry. There's the lead in and lead out there, just like we told it to. That piece.
that was our 0. That's where we started it. That's why it works out well for us. It's good for material, keeping track of material and how we're going to fit it. And there's our 2 pieces. So there you have it. That was a quick video. At least I hope it was a quick video, and I hope we were able to explain the post-processing, how to create a tool in Fusion 360 for plasma cutting, how to do a setup, and set it up to do the cut. Again, the information for our email will be in the description below. So go there, send us an email. We'll send you that file, no problem. And if you like the video, please give us a thumbs up and subscribe. Thanks again.